Hello everyone, I am Mahendrini Ariyachandra. In this presentation, I am going to give a brief explanation about our study titled Demystifying the Role of Information Manager in BIM-based projects. So during this presentation, I will be talking about the need of information manager and why we need to define the competencies of an information manager for BIM-based projects. Next, I am going to explain the research activities that we carried out, the conclusion derived, and the final outcome of the study. Building information modeling is a digital representation of the physical and functional information of construction projects. This digital representation usually contains a shared database that can facilitate the whole process of managing a building life cycle. So due to this shared database and the digital copy that can easily exchange among project team members, BIM encourages the combination of the roles of all stakeholders and increase the efficiency of the construction projects. So this has helped over the years to reduce the conflicts among team members. However, the legal issues attached to BIM-based projects making it difficult to set a clear data scope and the data access constraints, the copyright issues. So this is where having an in-house BIM specialist or employing a consultant to work with them to achieve would be a huge benefit. So this would ideally require a person with old and new skills as well as open mindset to adjust with the technologies and moreover to cope with the never-ending changes. So this person would ideally have interaction with the top management and the low-level workers of the project. The BIM protocol commissioned by the Construction Industry Council addressed the problems that are associated with the BIM. So the primary objective was to enable the production of building information models at defined stages of projects. Data is at very heart of the BIM. Without data, there is no information and therefore no knowledge and no value. A typical construction project involves many stakeholders, including contractor, architects, consultants, project managers, engineers, and building product manufacturers. The coordination of data exchange is at the very core of the success of the project to ensure the right data in the right format is delivered at the right time. The information manager role is very much important in this case for the coordination and management of the project delivery along with the set data. This would ideally eliminate all the issues related to BIM and its ownership. For example, copyright and legal issues. Therefore, the CIC BIM protocol recommends the appointment of an information manager who establishes and manages the common data environment, usually known as the shared online space that everyone in the project has access to, and overseeing the process of information management and exchange between all parties. With the introduction of the CIC BIM protocol, many project teams have become interested in upgrading their projects to BIM level 2. However, the majority of them ignored the importance of information manager and the expected competencies of him to perform duties as outlined in the protocol. Therefore, the current trend is to appoint someone from the project team and assign information manager's duties to that person for the sake of the appointment listed, but it is questionable whether this person is competent enough to perform the duties as outlined in the CIC BIM protocol. Also, we would like to highlight that there is no proper guideline that explains the competencies required of an information manager and the difference between information manager and any other prevailing professionals. This results in demanding unnecessary tasks from an information manager. So they are being pulled by in different directions with different interpretations, suggestions, and different tasks. This result to reduce the project performance as well. Therefore, in our study, we contend that there is an urgent need for competency level benchmarking of the role of information manager, which was set out as the objective of our study. To fulfill the said objective, we used a mixed research approach, comprises with a desk review, an informal public opinion study, and an expert interview. The desk review was aimed at identifying the main and subtask categories of an information manager using standard BIM guidelines such as Construction Industry Council, British Standard Institution, and BIM Task Group. So once we sorted the task, our next step was to sort competencies adhered with each of these tasks using an informal public opinion study. The study collected information from people who are knowledgeable about the nature and the expectations of the information manager. However, the data collected in the second part of the study needed further evaluation. Therefore, as the third stage of the study, we validated the collected data using expert interviews. We interviewed 10 experts involved at the senior level for more than 10 years who have had working experience in BIM projects. Using the desk review, we could derive 5 main task categories that contain 21 subtasks. The main categories represent subtasks that related to general management and BIM, construction technology and BIM, communication and information exchange skills, common data environment and IT services. Next, according to the opinion study carried out, we could derive 55 competencies that represented the 5 main categories identified in the desk review. Majority of the competencies were attributed to fulfilling the requirement of information management, therefore demanded the expertise of information management related to BIM procedures and software. The same degree of importance were attributed to the knowledge of construction in technology and construction administration. Therefore, the rest of the competencies covered project delivery processes, construction contractual agreements, and their information flows. Finally, the findings of the informal public opinion study had to be amended slightly based on the changes proposed by the experts who were interviewed. This finally gave 32 competencies, which covers the expertise related to 17 softwares as well. The finding of this study illustrated that information manager is not supposed to do BIM for other stakeholders of the project or information trade of the project. He should be more of a person who should rather have the capabilities of understanding and incorporating BIM procedures into traditional construction sequences. Our study also highlighted that the information manager has to be trained and well educated about BIM workflows, functions of BIM software, and all-inclusive operations in the field of IT related to construction industry. Additionally, the range of the knowledge and the capabilities of an information manager has to be a combination of construction technology and contract administration of BIM-based projects. The resulting competencies of the study considerably highlighted information manager within the BIM team, which is truly challenging to any of the existing professionals in the construction industry. Further, our study establishes that although the competencies required by an information manager in IT and BIM software fall within a broad area, the extent of the knowledge required is not very high, unlike in the case of IT specialists. Hence, our study concluded that the information manager has to be a profession that emerged from construction industry. Also, our study further suggested that the collective knowledge and the expertise of an information manager in the field of the construction seems to be tally with the knowledge of quantity surveys, although we suggest that this hypothesis needs a verification. We could identify several further research directions considering the limitations of the study. The outcome of our study can be further extended by developing a framework to compare the competencies expected from an information manager identified from the current study with the corresponding subtasks expected from the information manager as defined in other BIM protocols. This would determine any major differences between the two. Also, the competencies identified by our study can act as a basis for new educational and training programs which could be developed for the prospective information managers. The hypothesis suggested by the findings of the study can be further investigated by developing a framework that will enable construction professionals, especially quantity surveyors, to become information managers. Hence, we suggest to introduce an educational program for quantity surveys to fill the gap between an information manager and quantity survey. This program could be either a set of additional modules included in the programs meant for quantity surveys, or it can be a diploma or MSc program that's specifically intended for quantity surveys and containing modules related to BIM workflows, BIM software, and IT related operations. There were few limitations attached to our study that mainly restricted the choice of research methodology. This study was initially carried out in Sri Lanka, where BIM is yet to be implemented. This restricted the choice of the data collection. Another major limitation was that there aren't any published journals or conference papers focused specifically on the role of the information manager, which further restricted the authors to select a desk review as the data collection method. Besides, due to the numerous interpretations regarding the information manager's role, the identification of the role of the information manager had a diverse behavior. Therefore, in this study, we have considered the information manager role as defined in the CIC BIM protocol. That concludes our presentation. Thank you for listening.